Hi, I'm Shakti Perdana, a physics teacher who believes science is not just a formula, it is the stories of our world. Today, we will uncover how Indonesian musical instruments teach sound wave, whether we're in class, at home, or exploring cultural workshop.
This is a hands-on approach that blends smartphone technology with traditional musical instrument, emphasizing local wisdom. This tested strategy has been successfully implemented in 3 different modes: online during the pandemic, face-to-face in a laboratory setting, and in a flipped classroom format. These activities are tailored for both upper secondary students and lower secondary students with simplification of the data analysis. The materials are easily obtainable and include a bamboo flute or recorder as alternative, angklung, straw, coconut leaves, and VFox app and Nplot graphing software. Nplot is a free data analysis program ideal for introductory science lab, while VFox allows students to utilize sensors in their smartphone for experiment. These tools enhance the learning experience by making data collection interactive and engaging. We have 3 different experiments to explore, and you can choose one of the best fit your classroom resources, learning objectives, and lesson format. The alternative include 1. Measuring speed of sound using flute and smartphone. 2. Measuring the speed of sound using angklung and smartphone. And 3. Using a coconut leaf trumpet for measurement.
The core concept of this experiment is to use the musical instrument as the sound sources.
We relate the length of the air column to the wavelength produced by each tone in musical scale do, re, mi, fa, sol, la, ti. The frequency detected by VFox, along with a ruler to measure the air column length, allows us to calculate the speed of sound, taking into account whether the instrument is an open or closed tube. In a flipped classroom, students study the material before class. They watch a tutorial video on conducting the experiment and learn how to measure the speed of sound using the appropriate equation. If you have a field trip, detailed instructions are provided before visiting local craft workshop. On the day of the trip, students play or craft traditional instruments while recording data and completing the worksheet. We have conducted 2 learning journeys to the Angklung Craft Center, Sawung Ujo, and a traditional village. These experiences reinforce the practical application of physics in cultural contexts. We employ 2 assessment strategies. The first, performance assessment, utilizing a guided inquiry worksheet to enhance students' inquiry skills, like formulating hypotheses, defining variables, recording data, graphing, and drawing conclusion. Second, summative assessment, structured question and PISA-style questions to evaluate higher-order thinking skills. Why this strategy works? First, it works in any learning mode. Second, it connects abstract concept to cultural identity.
In conclusion, whether in person, remote, or during field trip, this strategy is adaptable because physics is everywhere.
When students see science reflected in their culture, learning becomes meaningful. Physics isn't just found in the textbook, it's rooted in our tradition.